So simplest way to understand the transistor. See, this is a transistor which is said to be NPN transistor. So this is NPN transistor, not towards the plate. It is away from the plate, arrow. So this is VBE and this is VCE. This is base emitter voltage and this is collector emitter voltage. You all know that this is going to be the collector terminal, this is going to be the emitter terminal, and this is going to be the base terminal here. So now base emitter junction is forward biased by VBB. Okay, and collector emitter junction is reverse biased, which is taken as VCC here. Okay, this is used to reverse bias the circuit and this is used to forward bias the circuit. How are you going to write the equations now? First and second. First is near the input. Near the input, we write this voltage VBB is equal to voltage across the base and voltage across base emitter junction, which is taken as VBB plus VBE. So whatever VBB you are taking, this is acting like input voltage as well as the voltage which is forward biasing the transistor. So we write VBB is equal to IBRB plus VBE. VBE. Okay, so this is VBE. Then after that, what you have to do here is, you all know that VBE is almost constant. So there means change in VBE is equal to 0. Therefore, if you want to take the change in VBB, if you change the input, what is going to happen? There is change in the current, that is delta IB RB, whereas there is no change because this is going to be constant. We can take it as 0. Therefore, this VBB is acting like an input voltage now. So input voltage is taken as delta IB RB. That's it. So this is acting like an input voltage. What is happening at the output? At the output, this is acting in the reverse bias condition, making the transistor in the reverse bias condition. So here we will take the output voltage VCC is acting like this is VC and this is VCE. Okay, here this is the output which is acting to reverse bias the transistor. That's it. Okay, so what is going to happen here? Here VCC is almost constant, therefore change in VCC will be 0. Anything is constant means there is no change in that, therefore it is taken as 0 here. Then after that, you will write this as 0 and this is taken as VC. Voltage across the collector is nothing but ICRC plus VCE. Okay, now we will take VCE is equal to minus ICRC. Okay, so now this VC is acting like an output here. Okay, so here this VBB is acting like input as well as the forward biasing, but whereas this VCC is acting only to reverse bias, whereas the output voltage is measured across VC. That is the difference between input and output. Therefore, V at the output is taken as minus ICRC. You all know that voltage gain is nothing but V output by V input. So we can take it as V output is nothing but IC by IB. This is taken as delta. Change is there means you can take delta if you want, doesn't matter, nothing happens. Here delta you can take. So after that, if you take delta IC by delta IB into RC by RB. Okay, so you have to remember one thing, that IC by IB is nothing but beta, and we can take this as RC by RB. So this is the voltage gain here, whereas the current gain is taken as beta, which is taken as delta IC by delta IB. This is a sweet and smart explanation of transistor in the CE configuration. So in this way we can find out the voltage gain here in any problem. So this is the circuit. What is the meaning of this negative? The meaning of the negative is if the input is a small wave, output you are getting a larger wave, but that too in the opposite direction. Here if it is negative first, you will positive will be, and if it is positive you will get negative at this place at the output. The reason is because output is negative times of the input. Here we will get minus at the output here. That's it. This is a simple sweet explanation of transistor. Thank you.